Chris. So, hi everyone, my name is Jay Parmar. I'm a senior architect at Snowflake Professional Services, and I lead the AI and ML practice for Europe from a professional services point of view. So I just don't talk the talk, I walk the walk too, so which is actually really good. So as part of today's session, we'll be exploring the potential of large language models, and we'll get to the details regarding how that works, right? Safe harbor slide, don't worry about that because I'll be talking about other stuff that's more important. So the agenda for my session today is, what are large language models? What are the different types? Where we're going to go? What shall we see? And what will be? And then finally, there's a live demo for you as well. Fingers crossed. So we'll see how this is. So what are LLMs? So if I had to ask yourselves, what are LLMs? And provide me with factual information in that context, what would be your answer? Who would be able to answer that for me? Go ahead. Okay. That's one. Next. Anyone else? Oh, this is a shy crowd. All right. Okay, fine. So realistically, based on that, LLM is literally an AI model which ultimately does a bunch of stuff and generates textual output, which is great. And that's great from a definition of LLM. So now, if I asked you, what are the different types of LLMs? Right? Can anyone answer that question? Right. What is the context here? You see it up on screen. What context do you see? The previous context that you saw is provide me with factual information. The context now says business user. So what would be the answer to this question? Bingo. You see? Exactly. Who cares or I don't care? As a business users do not have an idea about what different types of models are. What is it they're really interested in? And I think that's really the next question. Because if you think about your business as well, most organizations and business users will say, how can AI help my business? And think about this, right? I'm not going to ask you what it is, but just have an idea about how your business can leverage AI, right? In all its facets. And when you start thinking about that, you generally have this concept of providing a limited process of understanding. For most organizations, it's about streamlining business processes, generate value, or something in between. Now, how many of you thought about one of these instantaneously when I talked about AI and how you can help your business? Quite a few people. Okay, good. So from that perspective, that's great, but how do you get there? Right? How do you actually get there? And most organizations generally have, with AI, what do we know about AI? What does AI drive off from? Sorry? Data, correct. Right? So the next question is about data. So what types of data do we actually have in organizations? So ultimately, what you normally see is organizations are structured around two main components. You've got your structured data and your unstructured data. Which one's probably the more complex one to use? Okay. And why do you think that's the case? So Chris had one, so there's no metadata, right, to it, which is fair, but you can generate it, so that's one. But the whole purpose here is unstructured data doesn't, in its raw sense, doesn't give you much. And hence, that's the more complicated scenarios. And what does Gen AI solutions today respond back with? Does it? Well, structure could be one. Could provide metadata, but ultimately, it also provides unstructured data back as well. That's the whole purpose of generating text as well. So there's a bunch of stuff that happens. So when you're looking at the way that structured and unstructured data works, right? How do you gain access to get LLMs to actually work with both those scenarios? And in the Snowflake world, what we normally say is those two capabilities are driven off two different functions that Snowflake have. So we have something called Cortex within Snowflake. And as part of Cortex, we have different functions that are available. And these are services which are available, which is Cortex Search. It's a fully managed retrieval system that takes your unstructured data, processes it, creates vectors, for example, and then gives you the response that you need for your natural language question. So what you see here, you ask a query, it does a bunch of semantic lookups, keyword lexical lookups. It then orders your unstructured data in a way that tells you which one's the most relatively similar to the question you're asking, and provides you with a response back. That in itself is the way we currently handle unstructured data, which is your documents. Right? And it's quite an interesting thing, because if anyone saw my last demo from last year with unstructured data, what you normally see is that there's a whole raft of processes that need to be implemented first. First, you have to take the text out. Then you have to sort it. Then you have to make sure it's fit for purpose from a chunking perspective. Then you have to do vectorization and so on. All that kind of stuff is handled for you as part of this. And then you add it to a model, and it gives you a result. So, which is great. And that allows you, from a Cortex search perspective, allows you to work with unstructured data very easily. And a business user can use that. Cortex Analyst is our text to SQL accuracy. SQL normally works on structured data in that scenario. And what we have with our Cortex Analyst functions is the ability to actually talk to your data directly. You ask a question, and it gives you back your results based on whatever the table, technically in this case, will look like. Right? And it gives you much better accuracies than others, but I'm not going to get into the context of that. It's too political right now with everything going on. So when you're looking at AI and LLMs and everything else, it's how you stitch that all together. So on the left-hand side, what you see is that your structured and unstructured data exist. And in terms of your unstructured data, most organizations don't have one place where they store their unstructured data. Who uses SharePoint today? Who uses Google Drive today? Right? Anything else that you use today? Right? All those type of things, that's where most people master most of their documents. Confluence is another one, which some people use as well, but generally speaking, most of it sits in that scenario. So therefore, we've got all this structured data and a lot of these things, right? How do you get that information available from that repository? Make it available to be searched, and ask the right questions with all your data. Chris's point regarding metadata is actually really valuable, because with most documentation, hands up who's ever had a problem with trying to find what the latest information on what a document is. Pretty much everybody, right? And that's the hardest part with a lot of these things, finding what the most relevant document is and what's most up to date. And so as part of the work that generally I do with customers in trying to make sure that the documents we process and actually access are the most up to date, and you build that pipeline to making sure that you use the latest version of a doc. And the good thing about Cortex Search, which is on here as well, we are looking at automating the entire process already. So therefore, realistically, all you do for Cortex Search, you just point it to your document store, and it starts indexing straight away, which is actually pretty cool. No technical involvement, it just does it automatically. And the same thing with the unstructured data. So the only thing we have to do with Cortex Analyst is point it to your data set, and it generates most of the stuff for you. But the interesting thing is, with structured data, right, and in terms of tables and the way you access data in structured form, how many different ways is there to query it? There's quite a lot, isn't there? Right? If I've got a use case, which is finance data, who do you think the target persona would be to query that data? Someone in the finance team, right? Generally speaking. But then it could be someone from another team, right? The way they talk about the data, the way they look at those objects are very semantically different in terms of how they talk about. Some people might use specific keywords that they have within the organizations, like the definition of revenue, the definition of profit, and so on. A definition, oh, this is the best one. What is the definition of an active customer? Right? So from that perspective, all these business rules get applied. So you have to build, with Cortex Analyst, this concept of a semantic model. That's what the table semantics is all about. The semantic model helps you define what those business terms are, the business naming is. So when, for example, your table's got all this technical data in it, right, which doesn't really align with business definitions, how do you bridge that gap? These semantic models do that for you. And you help build that process to help you with that natural language to SQL, to execution, and to results. That is the way that most of our Cortex analysts work. And this is the good thing as well. Most text-to-SQL systems at the moment today, right? You generate SQL, great. How many times have you seen you generate SQL and it just doesn't run, right? It's quite a regular thing. One of the key things that we do as part of the Cortex analyst is it has agentic behavior and it's got its own models behind the scene, right? Which actually will make sure that that query can actually run before providing it back to the user. So these are systems to help business users actually run good, valid SQL. And it comes back to that point previously in terms of accuracy. Okay, so then you've got things like retrieval engines, which we've just talked about. Then you go to the concept of agents, right? Agents here are actually quite a big thing because what they do is bridge the gap between retrieval engines and Cortex, natural language prompts from applications. So as you notice here, you've got Slack, you've got Teams, you can whatever. You can connect directly to your data. You don't need to use third-party apps to be able to do that. How good would it be to be able to go to one place and just type your questions out and it gives you everything for you? Most people right now, and most customers right now, because of how early AI and the adoption of AI, they've got very fragmented capabilities that do different things. Ultimately, if you want to bring everything together, what's the best way to do that? And this is one way to do that with our Cortex agents. One of the key things that we've got as well as by agents is not just be able to do the orchestration, but also got things like monitor, iterate, and the AI observability piece. Observability is such a massive thing in this industry about knowing exactly what it's doing, how it's doing it, how accurate things are, how do you provide feedback, all that kind of stuff is all part of the concept of our Snowflake AI observability piece. So the future is AI agents for now, right? Because what you see is it provide accuracy, security, and within the Snowflake ecosystem, govern data access, right? And what we've noticed recently is when speaking with customers and actually building with customers, there's a whole bunch of use cases that can actually be defined quite easily, right? One of them could be the fact that you got product and brand planning. How many people have gone into ChatGPT or Snowflake Cortex or wherever just to actually take a look at, actually, give me some advice about how do I do my product, right? Well, what product gaps are we currently seeing? And to be fair, how many people have just used it for self-evaluation? Right? If you haven't used it for self-evaluation, use it. It's actually really good. It actually does give you a lot of insight. But ultimately, what you'll notice that there's a whole bunch of use cases that get driven off the agents. Like one of them, recently, I helped a customer do claims processing. And they've built an agent now. Is to, when a claim comes in, it automatically checks what type of claim it is, what happened, and then it also double checks what goes on with the contract, the documentation for that insurance provider, double checks a bunch of stuff regarding what happened with the incident, takes a look at the data, figures out, does it have all the information, right? Is the claim valid, right? If it's not valid, right, what's the next steps? It does all this automatically now. And what does it give you? It gives you faster response times to clear claims processing. How many people have been waiting around for ages for insurance claims to come through, right? It takes a long time, right? And especially if you've written off your vehicle, right, pretty much, then you need that money quick, to be fair. So that's the way to look at it. So data agents unlock it. And one of the nice LLMs that people talk about today is Claude, which Snowflake is available. And Claude's got like 3 different capabilities, right, for these state-of-the-art models: advanced reasoning, code generation, and multilingual. I've squared the red box here for a reason. The whole concept of agents and agentic behavior comes down to one thing: reasoning. Understanding and making the right decisions, like the human brain. Right? What agents normally do, they don't normally, in this context of an agent, they orchestrate, right? That's the key driver. So the reasoning part is part of the orchestration mechanism. Now, most agents come under a number of things, but how many people know how agents work, just as a matter of interest? Few. So normally, like, agents normally just don't do things themselves. They've got tools to help them out with, right? And they've got some memory. So they leverage tools to find out exactly what's good and what they should be leveraging in terms of what tool sets. So therefore, those tool sets that you define is what the agent has access to. So when you ask a question, which tool set would be the right choice in this scenario for this particular natural language question? So, and that's why I say advanced reasoning. But I also want to make another statement. There's large language models. There used to be something called, a long time ago, big data, if you remember, right? So, do we still use that term? No. Why don't we use that term today?
Well, because big language models had a different acronym which wasn't.
Because data, by definition, got larger and larger, and there was no differentiation. The way... Say that again? Yeah, exactly. It is ignored sometimes. However, one thing you'll notice, the definition of a large language model by itself, do you think that's going to stay to large language models? Right? And my personal view on this is that eventually we're going to get to a point which there won't be such thing as large language models or small language models, right? Or even tiny language model. The way I look at it, there's a specialized language models, right? Specialized in specific capabilities. Reasoning is one. So it's orchestration from a reasoning perspective is one. Code generation could be another one, right? Then you've got things like, for example, image recognition could be a different one as well. In your organization today, how many people have fine-tuned a language model today? One, right? And anyone else? Just one? No, for your organization, most organizations have to fine-tune to make sure it's applicable for their use cases, right? So to do that, right, now you've actually built your own specialized language model. Do you call that LLM? No, you call it's a fine-tuned model which is specialized for your purpose. The same concept applies. All language models eventually, regardless of the number of billions of parameters it has, right, will generally be specialized in specific scenarios. And that's one of the reasons why I'm always saying where the whole concept of LLMs will go, there's no such thing as LLMs. And the definition, the acronym SLM has been used for small, but I call it SP, specialized language models, is where the things are going to end up. And as we get more and more tool usage for every single agent, an agent can then use another language model, a specialized one, to do different things. So realistically, what you have, you've got models that use models that use models. And that also has eventually the definition of a multi-agent, multimodal capabilities across the estate for any organization. So that's why I would say Cortex agents, we've talked about the whole bridging the gap, but there's also things about making sure that we've got relevance, groundedness, and toxicity. All this stuff needs to be embedded into the process when you're actually building your agents themselves. So I'm going to just go do a demo. So just give me a second. So I've got some data, which for the sake of the demo, I've just done a couple of things. Right? So there's some customer order data, which is in a structured format, as you can see here. We've got some sales conversations which have been taken out. So that audio file's been processed, the information's been extracted and landed into a table. And then I'm a really massive Formula One fan, right? So therefore, I didn't want to read the entire Formula One document, which is this big document here, which is sport and regulations. It's got tons of data in it. If I want to ask questions on it, I want to be able to ask questions on it the way I want to do it. So therefore, there's all this document processing that's already been done to this one document, which I've chunked before, just for the sake of it. Now, all this information is available on here. Now, how do I bring all this stuff together? Right? So, but before we can start using agents, we want to start leveraging the unstructured and the structured component. So in Snowflake, what you have is you got the Cortex Search Service and Cortex Analyst. And to be able to create them, it's literally no code and low code. So you specify a few details, where your data sits. For example, let's just take a look at, I'm just going to put it in a more specific place. Just use it as an example for now. You specify the data that needs to be indexed in here. So you take a look at, hold on, we've got my one, rag one. This gives you the Formula One chunks in here. as you can see. These are the chunk documents. Say, yep, I'm really happy with that. Select the relative chunk you want to search on from a natural language perspective. Give it a bit more information, so we can skip it for now, and provide the columns to include in the service. Click next, and then you finish it, and it starts creating it based on the service. That's it. That creates your unstructured search process. No code written, no nothing. All low code, no code. So then we go back and say, actually, do you know what? I want to look at structured data today. So I'm going to try looking at the structured data set, and I said, well, actually, I want to take a look at my sales data. How quickly is it to set up a process to look at my structured data? So let's take a look, give it a description. We'll give it, say, just give me a second, pick a stage. Just call it model for now. So this is a semantic model we're building, right? So what this means, you're trying to bridge the gap between natural language processing and what the table looks like in this scenario. You can specify some examples, user questions. We want to take a look at some of the data that's available within tables. So some product order data, for example. Let's just take all 5 tables. Click on next. You want to do all of them. You want to select every single one of those tables, for example. Then it comes up with your model. Generate all for you. You can provide some like textual information. And normally, these textual information provides you that context in this scenario. So in this case, in this orders table, for example, it's got all the different dimensions, the table names, the column names, and so on, and all the definitions associated with that. Now, once you've done all that easy stuff, how do you then connect your agent to those tools? Easy. So we're going to launch. This is a custom Streamlit app that's been built that looks at the Cortex agent today. As you can see, what you'll notice, it comes back to different capabilities. So here we're specifying which model we're going to use for the reasoning side of things, right? So advanced reasoning for the orchestration. And we have to ask a question, right? There's no services currently set up at the moment. So if I ask a question, right, it just won't come back with anything because there's no tools provided. So let's give it some information. So what we're going to do is give it some context. So we're going to give it Cortex Search Services looks at unstructured data. So as I've said before, I love Formula One. So we're going to use that search service, which we've just done, and some conversational search, which is the natural language table that's looked at audio files, converted that to text, and made it available. And then off the back of it, we're also going to be doing a Cortex Analyst, which what we're going to do, it should be straightforward, is provide a location for the semantic models, add the service in, and that's it, the way we go. We just added tools to an agent. So now, what are my sales for the month of 2024? If I ask that question, it goes off, figures out, okay, what I need to do, what tools I have, then comes back with a specific answer, and it gives you that answer there. If I do this one, just give me a second, I'm just going to do a couple of things, actually, just to make things easier. Let's just take these 2 out for now. I'm just going to do that one again. So from the reasoning perspective, it's taking a look at that Cortex Analyst, it's looking at your sales data, and then off the back of it, it gives you a result about what your sales data looks like. So then it's providing me all my sales data for 2024. And then you can easily visualize it. And what it also did for you as well is create the SQL query for you, which is actually pretty handy, isn't it? So then we're like, all right, great. So it did all this by looking at what data we have, what options we have, and then generating the SQL for Cortex Analyst, executing that, and visualize that for you directly in one page. This is the next generation of self-service within your organization, right? This is where things are going. Businesses want to look at self-service capabilities within the organization. This is one way. So instead of using dashboards that are pre-generated and so on, give the ability for self-service users to actually query the data themselves. What they want to look at, specify those. Yeah, if you've got static dashboards that you need metrics for, that's fine, you can do that. However, for this case, right, if you want to have introspecting for every customer, this is how you do it. And then off the back of it, what I'm going to also do is, who likes Formula One? Good. All right, so I'm going to ask one question. Who wins the race if two drivers get the same lap time? For qualifying. So let's just rephrase it. Who qualifies pole position on the grid if two drivers have the same lap time during qualifying? Okay, let's find out if that's what it says in the regulations. According to the rules, if two or more drivers identical tap times during qualifying, priority will be given to the driver who set the time first. So what we've done here, we've brought loads of different tooling in, right, to be able to actually work with agents. So the tool aspects of it, the advanced reasoning and so on, are now full-fledged capabilities. We were able to build this agent with literally low or no code, right? And it was literally done like this within this, like, what, 5-10 minutes, right? Just imagine what you can do if you start working with all your data within your own ecosystem. So from that perspective, I think that's it. We'll see. Cool. So I'm pretty much bang on time, which is great. Does anyone have any questions? Oh, got a few. Go for it. Mike?
By the way, we have panels later, so if you don't get to ask your question now, because we've got lunch shortly,
Yep.
There's going to be Jay's on a panel later. So.
Would you recommend to use the self-serving AI engines for business-critical reports? Because users still have to validate the SQL, validate the data they are seeing, because they can still make things up. And now I imagine there's like a CEO going on with their agent, happily typing things in and want to make a decision based on the data it sees, but the data is wrong.
So I think to answer your question, if there's very specific types of queries that need to be generated for specific natural language questions, what we have in Snowflake is called verified queries, which means the fact that if you ask this particular question, this is the SQL statement that needs to be generated. So back to your point regarding mission critical or very critical types of queries, that's how that will be implemented. So this allows the organization to have queries that regularly get asked, right? They've got a fixed nature. But that also does one additional thing as well. It takes a look at that query that you've already defined and uses it as part of its own inference model to generate better queries based on what the business questions are. So does that answer your question? Good. Fantastic.
So we will save, because in the... So you can get to eat. If we go out for food now, there'll be time to answer questions later on the panel that Joe will be on. So yeah.
Cool.
Food time.
Great. Thank you very much, everyone.